Hello, this is Puluk. Today I'm going to discuss about Kubernetes Gateway API. Also show you a hands-on demo of Kubernetes Gateway API using GCP. In the demo part, I actually show you how can we expose a Kubernetes internal service into the open internet using Kubernetes Gateway API. But before that, let's know about what is Kubernetes Gateway API. So Kubernetes Gateway API is an open source project managed by the Kubernetes SIG network community, and it is actually created to evolve Kubernetes service networking through expressive, extensive, and role-oriented interfaces. To do so, it actually provides CRDs called gateway class, gateway, HTTP route, TCP route, GCP route, etc. So yeah, so now let's talk about the diagram of the Kubernetes role-based APIs. So first, there is a gateway class. So gateway class is kind of like of the ingress class. So infrastructure provider will create the gateway classes, and cluster operator will create the gateway. In the gateway, the cluster operator will mention the gateway class. And then actually the gateway class is a set of rules that the infrastructure provider have already specified, and cluster operator will just use that in the gateway. And then the application developer will actually create the HTTP route and provide the rules to route the external traffic into the services. So what's the benefit here about using this role-based API? Now, before, let's say if there are two application developer try to share the one ingress resource, then there is a chance that one application developer might reset some configuration made by another application developer. But when we are using gateway APIs, then we can see the application developer is actually using the different HTTP route, but share the common gateway. So in this way, there is no chance, almost less chance to developer for the application developer to make conflicts on the HTTP route. And another benefit is that now we can impose the RBAC based on the persona. Let's say the application developer should not have a permission to create the gateway, or the gateway operator might not have permission to create the gateway classes. Infrastructure provider can only the create gateway class. So in this way, you can now give permission in a more distributed way. That is not been possible when we are using ingress. So yeah, now if I talk briefly about the ingress versus gateway API, if I already said that now you can provide the roles and responsibilities in a more distributed way. And another thing is that in ingress, if you want to use the CANI deployment with the weighted traffic or the HTTP header base matching, then you have to uh, add specify the annotations. But in the gateway API, things are more convenient. Now you can provide you can specify those things in the CRD field. So then also specify how many percentage traffic will be routed to which app. We'll see the CRD soon. And the third point is that you can use the shared gateway and cross namespace support. That means if you have two teams like dev or QA, then the both can share the same gateway, even if they are from the different namespaces. So now let's see the demo. So for the demo, I'm using a standard GKE cluster. So by default, in GKE cluster, the gateway API is not enabled. To enable the gateway API, you need to use this command that is I have shown in the slide. So let's jump into our terminal. So I have already enabled the gateway API. So let's check the gateway classes. Here is the 4 class by default come with the GKE cluster. So we are going to use the GKE L7 global external managed one. So let's check this one. Yeah, so this one is pretty simple. In the spec section, we can see only the controller name and a small description. And in status section, the status accepted. In the controller name is used the GKE API group, that is networking.gke.io/gateway. And in the description, it is containing a small description, that is preview class for the new L7 external load balancer. Okay, so we need to create a gateway. So, but before that, for the demo purpose, let's create a service of or deployment of a Nginx in the demo namespace. We have already a deployment, so I believe we have also a service. Yeah, we have also a service. Let's check those first. Yeah, we have the deployment already, and also check the services from the demo namespace. Okay, so let's check port forwarding and check that can we access it from locally. Yeah, we can check it that it is accessible locally. So now let's expose it to the internet. So to do so, we need to create the gateway resource. So let's check our gateway resource. So here is our gateway resource. So in the spec, we have mentioned the gateway class, that is GKE L7 global external managed, and in the listener we have provided that it is HTTPS 443, and for that we have to provide a host. We're providing a host name, so we can use this. And in the TLS part, we are provide the secret. So let's check our secret. Okay, so let's create our secret. So for this demo, we are going to use a self-sign certificate. So to create this self-sign certificate, you can use these commands using OpenSSL. So by the first command, we are going to create a private key and also a CSR, that is certificate signing request. So we can skip those fields until common name. We have to provide the common name that we are going to use the example.com, and we can skip the other fields as well. So okay, let's sign our CSR using our private key. Okay, now let's create our secret. In the demo namespaces. Okay, so our secret name is my secret, as we are also mentioned here in the certificate ref, the TLS, and we are also using the mode terminate. So the gateway will terminate the TLS on the gateway. Okay, so let's create our gateway from terminal. Let's clear it. Okay, apply. Okay, so our external gateway is created. Let's check it. Yeah, we can see the external HTTP is created. We can also check the YAML and also check the condition. Yeah, so it is not still wait for the reconciliation. So it will take some time. In the meantime, let's check our external route, that is the HTTP route. So in the HTTP route, in the spec section, we have to specify the parent ref. In the parent ref, we are giving the gateway that we just created, external HTTP. And in the rules section, we have to provide the rules like the backend ref, kind of like the ingress rule. And here we are said that we want to expose our Nginx ingress service, and it will based on not it can be based on header based or even path based. So we are here using the path based. So okay, even if you want to use, let's say, uh, if you want to deploy a canary deployment, like we have already a deployment or service, let's say store v1, and we have a new version of store v1 that is called, we are calling store v2. Now we want that our 10% traffic should be in the store v2, so we can check that everything is fine before full scale deployment. So we can then specify like this, that 90% traffic will remain on the store v1, but the 10% traffic will route it to the store v2, and we can check that everything is fine. So yeah, so now let's check our external gateway status. Yeah, so here we can see the status section. It is created a load balancer. We have provided the IP of the load balancer, and also there are some conditions, and also there is a listener part. So we can see the attached route is 0 because we had to create our route, and it also said that the supported kind is HTTP route. So let's create our HTTP route, that is external route.yaml. Yeah, let's check it. Yeah, it is created. Let's check the YAML. Yeah, there is yet no status, so it will take some time to reconcile. In the meantime, let's as we are going to use a host, that is example.com, but for the demo we have to update our etcd host with the IP. So let's collect the IP from the gateway API. So now let's update for the host with the given IP. Okay, so now let's check our HTTP route status. It should be reconciled in the meantime. Yes, it is reconciled. Now you can see some status, and so say it is said that the parent ref is external HTTP. We can also check our gateway API status. Gateway status. Here now we can see the attached route is 1. So now let's try to access it from the browser. Yeah, it will take some time to become live in the Nginx. Let's wait a bit. In the meantime, let's check the status. Yeah, so finally I can see it is here. So it is showing the not secure because we are using the self-signed certificate. So if you want to see the gateway API webs doc, check the implementations, that the current project status. So here's the, it actually gateway API is like the ingress, so it's not coming out coming with the implementation. So you have to implement, or the somehow need operator to make it functional for the those network rules. So here's the current implementation with the status, also some integration like Flagger and Cert Manager, Argo, Aroloser Knative, try to integrate it. And there's some implementation. Today we have used Google Kubernetes engine. That's the currently in GA. So yeah, so that's all. for today. So yeah, thank you. If you want to follow me, then you can follow me in Twitter. Also, you can follow me in GitHub. That's it. If you want to see the similar videos, then you can comment on the comment section. Then I will create new videos on like HTTP header base matching, or let's say some CANI deployment. Please share your thoughts. Till then, take care. Tata.